Marion!
So in this video, we're doing a live recording and going over some of the problems where we are talking about graphing rational functions, and we're going to go over example 1 part B, which was due for the first day's class in this particular lesson. And so what we're going to do is rather quickly just go through each of the steps that we want to go through in order to get through this graph well. So the first thing that you guys probably did, hopefully, is set the numerator equal to 0, which is just going to be x equals 0, and that gives you your x-intercepts, right? So if you didn't do that, and you're watching, you probably should just do that. And x-intercept of 0 just means that the graph will hit the origin. So I can put a point right at the origin immediately. After you do that, you probably try to get the vertical asymptote by setting the denominator equal to 0. So if you set x squared plus 1 equal to 0 and solve, do you guys remember what you got? Go ahead.
Plus or minus I.
Plus or minus I. You'll end up with something imaginary. You get x equals plus or minus I if you solve that correctly. Guys, you cannot plot an imaginary coordinate on the real plane, the real coordinate plane. So what that really in fact means is there is no vertical asymptote, just like I think part A was. So right away, since there's no vertical asymptote, what I would do if this was a quiz or a test is I would put there's none right there. And I also know, if I know what information about my vertical asymptote, I can fill out information regarding my domain. If there's no vertical asymptote, then there's no restriction on what I can plug in. So for domain, I'm going to put in all real numbers. Okay, and I can do that right off the bat. Now for the tougher part. The third thing you're going to want to do is figure out what is the non-vertical asymptote. So for the non-vertical asymptote, I hope you compared the degree of the numerator to the degree of the denominator. So if you look at the numerator of this guy, it's really a 1. And when you look at the denominator, you see an x squared. So the degree of the numerator, I'm going to just say the degree of the top, was 1 when you compare that to the degree of the denominator, or the bottom. Let's just use bottom. That was 2. So since the degree of the top is less than the degree of the bottom, if you recalled what the different cases were, I think that was case 1, where you get y equals 0. Anytime the degree of the top is less than the bottom, it's going to be y equals 0. And that means you're going to graph an asymptote that goes right through the origin where you plotted a point, and you have that dashed line there. I'm going to fill out my horizontal asymptote as y equals 0 right away on the bottom. Now, at this point, if you were doing this at home or on your own, you might have realized something that bothered you. Does anybody want to volunteer? What is maybe the goofy thing about what just happened? Go ahead.
There's a point on the origin.
There's a point on the origin, and you put an asymptote right through it. Okay, and that's never happened before. And you might be thinking, I thought Mr. Schultz said you can't hit an asymptote. I said you never could hit a vertical asymptote. You can actually cross through horizontal asymptotes, okay? The way you have to start thinking about non-vertical asymptotes, like these horizontal ones and eventually the slanted ones, is that they tell you more about the end behavior of the graph. By that I mean, as you move away from the origin, I can tell just by looking at this that the graph is going to be drawn towards that horizontal asymptote. So I don't know what's going on over here, but as I move across the page, I'm going to end up going towards that asymptote. And same thing on this side. I've used the analogy in the past, and I kind of like it. I don't know if anybody else likes it, but I like it. Where if you imagine there was kind of like a vacuum cleaner hose, okay, that's stuck on the end of your horizontal asymptote, and it's on high power, and it's going to, I don't care what's going on with the graph over here, but it's going to be drawn in to that hose going that way and that way. Okay, so there could be all kind of craziness in the middle, but it's going to be drawn into that hose or towards that horizontal asymptote at the very end. So let me undo that mess because that's obviously not right. The reason why, I wonder if anybody can think about, why do you think it might be true that in this problem, looking at the equation the way it is, why is it when you plug in really, really big values of x, Why am I getting close to an output of 0? It's okay to be wrong, even though it's going to be on a recording. If no one wants to take a stab. How about looking at, oh, I should probably write it here. If you take a look at your equation, guys, if I plugged in x is 100, right? If you put 100 in the top, you get 100, and you might be thinking that's a nice big number. However, that pales in comparison if you did 100 squared plus 1 in the bottom. What happens if you divide a relatively small number, 100, by a really, really huge number? What is that really close to?
0.
That's really close to 0. So that's why, guys, when you have a degree that's smaller in the top than it is in the bottom, when you plug in huge numbers, you're going to end up getting a really small number in the top over a huge number in the bottom, and that will make it closer to 0. That's why y equals 0 is the horizontal asymptote, if that makes sense. So I'm not going to quiz you on that necessarily. You just need to know how to apply it, not necessarily why it works, but it's sometimes nice to know why. At this point, we're ready to plug in some coordinates, and you might be thinking, thank God, we're ready to plug in some coordinates. I hope you didn't bother plugging in 0, because you already know what you get. You get 0. But if you plug in 1, now this is where most students make mistakes, is just plugging in coordinates, as I said. So do some work in your head, but also write down what you're doing in the meantime. So if I plug in 1, I know I get 1 over, and if I do 1 squared plus 1, that's going to be 1 plus 1, I get a half. So if you plot 1, you get a half, which is right about there. If you plot 2, you're going to put 2 in the top. That doesn't look like a good 2. You put 2 in the top, and then you got to do 2 squared plus 1. That's going to be 4 plus 1, or 5. So 2/5 is 0.4. Notice that's a little less than a half. So it's not a great graph. It's kind of hard to be that precise, right, to show it that it's going downwards. If you plug in 3, you end up with 3, I think, over 10, which is 0.3. I think at this point, guys, you might realize, what are my coordinates getting closer and closer to? 0, right? The further along I go to the right, it's going to get closer to 0. So I'm going to go ahead and just finish this off. I'm going to go upwards, and then this thing gets closer and closer to the horizontal asymptote. I'm just going to put a little arrow on it going like that. If you go the other direction, let me get rid of my vacuum hose. If I go the other direction and I plug in a -1, in the numerator I get -1. The denominator I get -1 squared is still +1, right? And 1 plus 1 would be 2. This is where I think, when I was walking around checking homework, some of you guys accidentally plotted the wrong coordinate. You get -1/2 down there. If you plug in -2, I think you get -2 over +5. You'd get -0.4, which is a little bit higher than -0.5. So as you go to the left, you hit that -1/2, and then you move upwards towards that horizontal asymptote going on to the left. So you get this little wave deal that goes kind of across the page from left to right. Does anybody have any questions they'd like to ask? I'm just graphing this at this point. Okay, it's okay if you don't have any questions. It would be fine if you did. Now, at the end of the day, the range is kind of hard to do, and you need to look at your final graph in order to figure out the range. When I look at the range, I look at how far up and down my graph goes along the y-axis. So the highest output I got for y was right at +1/2, and the lowest output was down here at -1/2. I didn't get any y values that were bigger than or less than that. They were all sandwiched in between positive and -1/2. So I'm going to write an inequality, a compound and inequality, that says all of my outputs are greater than or equal to -1/2 and less than or equal to +1/2. It's kind of hard to see there, isn't it? So if you didn't get this, guys, please write this down. It was -1/2, less than or equal to y, less than or equal to +1/2. So that's the way you can write all y values that are greater than or equal to that low value, -1/2, and less than or equal to +1/2. Okay, we have a little bit of time. We're going to do one more example with you guys. Let's go to the next slide. This one is like the coolest graph you've ever done in your math lives by far. Can't wait to do this one with you guys. Now, we're going to roll through some of these steps quickly. First step, x-intercepts. What am I setting equal to 0, guys? Numerator. Let's do 3x squared. Set it equal to 0. When does 3x squared equal 0? When x is 0. So let's plot 0 on our graph right there. Now we're going to go ahead and do our vertical asymptote. If we do the vertical asymptote, we have to set what equal to 0? Denominator. Let's do x squared minus 4. Set that guy equal to 0. Now, this is an easy one to solve if we take square root. So I'm going to add 4 to both sides. I get x squared equals 4. And when I square root, what do I get?
2.
Ooh. Plus or minus 2. Ooh, this is awesome. That means we get 2 vertical asymptotes. One at x equals 2. One at x equals negative 2. How bizarre. Let's dash in one at 2. Oops, I don't want to do that. 1 at 2, so we get one like that. 1 at negative 2. Like that. I'm going to write in my vertical asymptotes. X is 2 and x equals negative 2. Do I have a volunteer that doesn't mind going for the domain now that we have our vertical asymptotes down? Anybody think they know? Our domain is going to be everything but... You got it. X can't be equal to 2 or negative 2. You can't hit those vertical asymptotes, so we can fill that out. The other thing to keep in mind is this, guys. Vertical asymptotes section off your graph. If you think about the hyperbolas we did in the last section, there was one vertical asymptote. How many pieces of graph were there? How many parts of the graph? 2. If you have 2 vertical asymptotes, we're going to have something going on over here, one piece, another piece in the middle, and a third piece on that side. There's going to be 3 different sections of graph in this particular example. Okay, so that's something just to keep in mind. Our last step here, we want to get our non-vertical asymptote. To do that, we have to investigate the degree. If you look at the degree here in the numerator, it's 2, and in the denominator, it's also 2. So here, we have 2 equals 2. The top degree equals the bottom degree. If you remember, that's case 2. That's when you're going to do y equals the leading coefficient over the leading coefficient. So I'm just going to write lead over lead, if that's okay, to save a little bit of time. The leading coefficient of the numerator polynomial is 3. The leading coefficient of the denominator, 1. So our horizontal asymptote, in other words, is just y equals 3. I'm going to dash in y equals 3. And you can see, just plotting the asymptotes is like making a graph. And we didn't even graph anything yet. So horizontal asymptote, I'm going to fill in the blank in the bottom, y equals 3. I'm going to stop right now and see if there are any questions that anybody would like to ask before we plot points. Okay, this is the part where we sometimes make mistakes from silly arithmetic errors. Let's make an XY table. What I'm going to first consider, guys, is I want to see what's going on in this section of the graph. So what I would do is plot some x values that are right next to my vertical asymptote, like maybe negative 3 and negative 4 right there. So if I plug in negative 3, I'm going to do a little bit of work in my head, but I'm also going to write stuff down. If I square negative 3, I get 9 in the top, and 9 times 3 is going to be 27, and then that's going to be divided by negative 3 squared is 9, and 9 minus 4 is 5. So I have 27 over 5. I think that's going to be 5 and 2/5, or 5.4. So if I plot that, I'm going to go up 1, 2, 3, 4, 5.4. You get a point right about there. I'm going to plot another coordinate. If I plug in negative 4. Negative 4 squared in the top would be 16. 16 times 3, I think, is 48. And if you divide 48 by, that's going to be negative 4 squared is 16. 16 minus 4 is 12. And that's actually pretty nice. 48 divided by 12 is 4. So we can plug in and plot a 4 right there. Now check this out. The vertical asymptote, remember, acts like a wall. I'm not going to go through it. Remember the vacuum cleaner at the end of the horizontal asymptote over here? These coordinates are going to be drawn closer and closer and closer into that vacuum, or closer to that horizontal asymptote. And as you move to the right, you're forced upwards by the vertical asymptote, like such. Now to figure out what's going on in the center, I'm going to plug in 1. I'm going to go a little bit faster so we can get it in. If you plug in 1, I'm going to do it quickly. I think you end up with 3. Get rid of that. 3 over negative 3, which would be negative 1. So if I plot in 1, I get out negative 1. If I plug in negative 1, I think you're also going to get 3 over negative 3. You'll get negative 1. So when you plot negative 1, you also get that coordinate. What do you think you get in the middle here? What is that going to look like?
U-shape.
Little U-shaped, like little mini parabola guy. So it goes like this, whoop, whoop, like that. My last thing I'm going to do is figure out what in the world's going on over here. I'm going to plug in positive 3 and positive 4. Now check this out, guys. All of my inputs, when I plug in an x value, what am I doing to that x value? Squaring. Does it matter then if I plug in a 3 or a negative 3 if I square it?
No.
No. So my output for 3 is still going to be 5 and 2/5. If I plug in 4, I'm going to get the same as I did when I plugged in negative 4. I'm going to get a 4. So I'm going to get the following points. When I plug in negative 3, or excuse me, positive 3, I'm going to get 5 and 0.4. So something like up there. When I plug in 4, I'm going to get out 4. And I get another little kind of branch of a hyperbola that goes along the horizontal asymptote to the right and up towards the vertical as I move to the left. Tell me that is not the coolest looking graph you've ever made. Thank you for telling me that. Guys, thanks for watching, and hopefully this will help you if you watch it again.